Welcome back to CAD/CAM tutorial. Today we are going to design a simple single cylinder engine in Solidworks. You can see it here. We will give the animation at the end of this video. It is very useful video for beginners and newcomers in Solidworks. Even it's good for immediate level. I hope you like it. So let's see how to do in Solidworks. We will make each and every part and assemble at the end. So let's start. Now here let's start the first part of engine, piston. So select right plane, sketch, select here line and start from origin. A horizontal line, then vertical, then small exit. Now see, we created this geometry, so let's assign the dimension. Width is 30 mm and keep the height 60 mm. Bottom edge let's make 4 mm. This edge let's keep 6 mm. Let's define the angle 130 degree. 10 mm. Select both the corners. 15 mm. And keep the degree 130 mm. .5 mm. Keep 6 mm. That's it. Okay, now here choose corner rectangle, and here we want to make some cutouts, so keep here 3 number of cutouts. Exit, choose trim entity and trim this mid lines. Undo the process. We want to cut this trim entity, trim to closest and select this inside. Okay. Now let's define this 2 mm. Let's make the gap 1.5 mm. Same 1.5 mm. Keep 2 mm. Okay. Select these 3 lines, make relation collinear and equal, and this one make 1.5. Okay, see the every distance 1.5 mm. Fully defined, calculate. Okay, now this geometry is fully defined. Again we can select fully defined the sketch, calculate. Okay, now here select revolve boss base. Select this line as a axis. Okay. Now see, let's create one plane. So select right plane, plane, and we want to create a plane 10 mm ahead. Okay, select this plane, sketch, draw a circle, center point, and just connect from origin point to, let's define this length 38 mm and the diameter 25 mm. Okay, now we want to extrude. Now just we will see inside extruded boss. Select here up to body, select this body, see, keep reverse direction, see here. Okay, now you can see. Now we want to make mirror, so again choose right plane, mirror, and select this extruded boss. See, here is going to mirror. Okay, that's it, it's mirror. Now we want to make a hole here, so select right plane, sketch, normal, make this circle visible, show circle, and draw one circle, and this time keep the diameter 18 mm. Okay, now select here extruded cut. See, it's keep end condition mid plane and select this 60 70 so that it will cut both side. Okay, see here. Now hide this plane. Let's hide this geometry. Plane, right plane and plane, and we want to create one more plane. Keep 30 mm. See. Okay, now select this plane 2, sketch, normal, and here draw a center rectangle. Find out the center point of this circle. Okay, now let's define 35 by 35 mm. Okay, now select extruded cut. Cut inside 3 mm and keep the degree 20. See, here it's going to cut. Okay, now see, hide the plane. Now it's time to mirror. First let's assign the material. Go to appearance, drop down, choose here metal, steel, and I prefer here satin finish stainless steel. So this looking a nice material. Now select right plane, mirror, and select this cutout, extruded cut 2. Okay, now see, it's mirror. Choose here chamfer, select both the corner 1 mm 45 degree. That's it. Again choose chamfer. This time choose here distance 1 by 1. Select and select this top ring, top corner. Okay, that's it. Now we want to make some cutouts. So choose here right plane, sketch, normal. Select here center point arc. First define center point. exit. Select both the end points, make relation horizontal. Now select here spline. Start from this point to this point and up to this line. Exit. Let's define this. First define this radius 15 mm. Now this point from this corner point 6 mm, (12 mm) and this point from outer line 20 mm and this point from cancel. Let's first cancel. Let's mirror. Select this arc and I think we need to draw a center line. First draw a center line. Make sure a vertical center line. Now let's try mirror this spline against center line. Okay, choose a line, select both the end, connect both the end, exit. Now let's try to make this last point. I think we are not able to find the exact point, so this one we need 11, so let's define from here 30 minus 11. Okay, this is sufficient. Okay, okay, this is better. Now select extruded cut. Keep end condition mid plane and this one make more than 60, so it will cut both direction. Okay, now see, we made some cutouts here. Now it's time to add some fillet. Select both the faces, 2 mm radius, again choose fillet. Select inside face and this face. We will try this face also, outer face. Okay, that's it. So this is our piston. Now let's save this piston. Desktop, and first create here one folder, engine. Make the first part piston head. Save. Now let's do the another part of engine, connecting rod. Here let's make the next part, connecting rod. Right plane, sketch and select circle. Draw 2 circles from origin. Okay, just come down and draw one more circle. Select center line and connect both these points. Okay, now let's define outer diameter 25 mm and keep inner diameter 18 mm, and this diameter let's say 45 mm, and overall distance 120.4 mm. Okay, select here line, exit, define this end point from this line, midline 35 mm. Okay, select mirror entities, select this line and mirror against center line. Okay, now see here, choose trim entity and trim this half circle. Okay, offset entity, select 3 mm and select this circle. See here, it's going to, okay, close both the end. That's it. Now here select this face, escape, line, select this point to this face, exit. Let's define this point from here, keep distance 8 mm and let's make the angle, keep 5 degree. Okay, let's mirror this line, mirror against this center line. Okay, see here, now our geometry is fully defined, so simply exit, select here, go to feature and find out extruded boss, select this circle, end condition mid plane 20 mm. Okay, again choose extruded boss, select this geometry, extruded boss, and this time select this bottom face, mid plane, and make the end condition 30 mm. Okay, that's it. See here, now it's time to middle portion, select this first geometry, sketch, now select mid geometry, mid plane, and 15 mm the mid distance. Okay, make sure merge. Now this is the our geometry. Select this face, sketch, normal, draw a center line, exit, select here corner rectangle. Now select these 3 lines and make relation symmetric. Okay, select directly circle and draw a circle up to this point, exit, trim entity and trim this half circle. Cancel, just make undo. I think we need to make circle here, so delete it, circle, draw a circle up to this line, exit. Now select these 2 lines and make relation tangent. Okay, now select trim entity, trim this. Okay, now let's define radius 6 mm, keep 12 mm. That's it. Now select extruded boss, select this full geometry and extrude up to 15 mm. Make sure merge. Okay. Now see. Now select this face, sketch, and draw here a circle. Find out midpoint and keep the diameter 6.5 mm. Okay. Select extruded cut and choose end condition through all. Okay. Now see, we created a hole here. Now we want to mirror this. Select front plane, mirror. Select this body and this cutout. See, it's going to mirror here. Okay. Select this face, sketch, normal. Select this circle, inner circle. Go to sketch, convert entities. Again choose circle and connect this end. Okay. Extruded cut. See, we want to cut these extra faces inside the body through all. Okay. That's it. This face is sketch, normal. Now select directly convert entities. It's converted. Choose offset entity, select this outer line. Reverse direction 3 mm. Okay. Extruded cut. Now select here this inside face only. We want to cut this inside face, 5 mm depth. Okay. See, let's make the mirror. So select right plane, mirror, and select this cutout. See, it's going to mirror in opposite direction. Okay. See. Now let's define some fillet. So select this edge and inside edge. Select this face, inside face. I prefer to select all the faces. Okay. Now in every places we have. That's enough. Let's make the material. Go to appearance and metal and find out chrome plate. That's it. I prefer to add chrome finish material so it looks shiny. Let's save this part. Part number 2, connecting rod. Connecting rod. Save. Let's make the next part, connecting rod cover, so that it will cover from one end. Here the next part is connecting rod cover. So choose here front plane, sketch, select circle, select line, exit. Let's define one center line. Now it's time to define the diameter. keep 45 mm and the distance from outer line 35 mm. Okay, now let's mirror this line against center line. Okay, trim entity and trim the half circle. Offset entity, keep 3 mm and select this circle. Okay, select line and close both the end. Exit. Select here extruded boss. End condition mid plane and 30 mm. Okay. Now select this surface plane and create one plane above this 12 mm. 12 mm above this plane. Okay. Now select this plane, sketch normal, define a center line. Corner rectangle, exit, collinear, circle, define circle up to this point, exit. Select these two lines and make relation tangent. That's it. Now define the diameter 12 mm. Okay, let's try to edit some, delete this inside lines. Okay, now define this length 10 mm. Okay, now select extruded boss, reverse, and select here up to body. Select this body. Okay, now hide this plane. Sorry, hide. Now again select this surface, sketch, and here we want to create a hole. Select circle, just click, keep mouse here so you will find out the origin point, and keep the diameter 6.5 mm. Okay, select extruded cut and keep end condition through all. Okay, see a throughout hole created. Now it's time to mirror this face. Select front plane, mirror, select this body and this hole. See here. Okay, now see its mirror. Fillet, keep 1 mm. Select first these two faces, then back face, try to select maximum edges where you want to fix. Okay, now define the material chrome plate. See, fillet 2 mm, clear, select this edge. I think let's keep as it is. So this is our cover. Save part number 3. Connecting rod cover. Save. Let's do the next part. Let's do the next part. Crankshaft rod. Crankshaft. Right plane, sketch and draw a circle here from mid plane. Keep diameter 45 mm and extrude up to, keep mid plane 30 mm. Okay. Now select this outer face, sketch, select offset, keep offset 3 mm only. See this line offset from this line 3 mm. Okay. Extrude only up to 2 mm. Okay. Now see, now select this face, sketch, normal, again choose offset and this time keep 5 mm. Okay. Center line, draw a vertical center line 40 mm. Okay. Select line, circle and draw a big circle. Let's keep the diameter 120 mm. Okay. Select here line, select and connect this point, exit. Now let's define (20 mm). Okay. Select mirror entity and mirror these two lines against vertical line. Okay. Choose offset entity. Okay, now this is our geometry. Okay, select extruded boss. See, and extrude up to 20 mm. Okay. See, select front plane, sketch, normal, select line and draw a line from here to this point up to this point, exit, and select here spline, exit, choose 3-point arc. This is quite better than spline in this condition. Keep little taper, exit, define 10 mm and vertical distance, let's say 89 mm. Okay, this any diameter, we don't. Select extruded cut, select here end condition mid plane and select cut. We want to cut through all, so choose maximum distance. Okay. Now see, we cut a taper, select this face, (100 mm), keep fillet, okay. See, chamfer. Now select 2 mm 45 degree, select this edge and this backside edge, See, it's all become chamfer. Now select right plane, and create one plane 60 mm. Okay, now select this plane, sketch normal, and let's draw a circle. Keep the distance 40 mm and the diameter 45 mm. Okay, now make one relation: origin point and whole circle center point vertical. Select extruded boss, select up to body. Okay, see, now hide this plane, select this face, sketch, and draw here one more circle. Find out mid plane, keep the diameter 30 mm and extrude it up to 15 mm. Okay, now you can see here. Again select this face, sketch, and draw here midpoint and draw a circle with 25 mm diameter. Okay, and extrude it up to 50 mm long. See, okay. Now we want to create some planes. Select top plane, 27.5 mm. Okay, now select this plane number 2. Again click plane, select this face, and here select degree 180. See, plane 2 in 180 degree face tangent. Okay, now hide this plane. Now select this plane third, sketch, and draw one spline cut, construction line, then choose here center point straight slot. Now let's define. (20 mm), radius keep 4 mm, and distance from outer edge 8 mm. Okay, select extruded cut, cut up to 4 mm, make the depth 4 mm. Okay, now this is the spline cut. Now hide this plane. Now it's time to mirror the body. So select here right plane, mirror, select mirror feature, this body, see, all the faces we selected. This cutout also important. Select OK, or better to select bodies. Select this body. Okay, that's it. See, Now select this backside faces sketch. Select the outer circle, convert entity, go to feature and select extruded cut. And this whole portion we want to cut. Select here reverse and select all. OK. That's it. Now this is our chamfer ready. Connecting rod is ready. So select appearance, and I prefer to add some material. Satin finish chrome plate. Save. Part number 4, crankshaft. Save. Let's make the driving gear part 1. Right plane sketch and draw a circle with 60 mm diameter. Make sure from origin point, diameter 60 mm, and extrude it 15 mm, and let's say end condition mid plane. Okay, select this face sketch, and here we will make the teeth for gear. So draw a center line. Select the line and make relation vertical. Center point arc. Start from origin point to this point and up to here. Exit. Make one relation. Select both the end point horizontal. Okay. Select line. Select both the end point and midline and make relation symmetric. Okay. Let's define the dimension. 1.5 mm and 4 mm, and the distance from here to exit first. Select spline, connect, delete it. We prefer 3-point arc. Keep little taper, not much. Now define the distance 6 mm. Okay. Choose mirror, select this spline and mirror against this midline. Okay. Okay. Now select extruded boss. Select here up to surface. Select this back surface. Now you can see the thread. Okay. Now it's time to make multiple number of thread. So first select here view temporary axis. See, this is the temporary axis. Select this mid temporary axis, circular pattern. See, here's axis selected. Select this extruded face or teeth. Make 16 number of teeth. Okay. Now hide the temporary axis. See. Now right plane sketch and draw a circle here. 40 mm. Okay, and extrude it. End condition mid plane 36 mm. Okay, see, select the outer face, sketch normal, and here we will make the whole shaft hole. So circle, center line, and draw a vertical center line. Diameter 25 mm. Okay, select here line, exit both the end point and center line, and create relation symmetric 8 mm. Okay, up to this line, and again select up to circle. Now define the distance from midpoint to this upper line 15 mm. Okay, trim entity, select here trim to closest and trim this inside lines. Okay, see here geometry is fully defined, so select extruded cut. Keep here end condition through all. Okay, that's it. See, so this is our driving gear, first gear ready. There are 2 driving gears. So let's define the material. Better define, we will give some color to identify. This is quite better. I prefer to give this color. Okay, now make the part number 5 gear 1. Save. Let's do the next gear. Let's do the next gear, driving gear, part number 2. Right plane, sketch, and draw a circle with origin point and keep the diameter 120 mm and extrude it 15 mm and keep end condition mid plane. Okay, now select this face, sketch, and here we want to create some teeth. Draw a vertical center line. Exit, make sure it is vertical. Center line point arc, start from origin point up to here, exit. Now create one relation. Select both the end point of arc and make relation symmetry, horizontal. Select line, select both the end point and center line and make relation symmetric. Okay, now it's time to define 1.5 mm. Distance from here to this point 6.267 and define 4 mm. Okay, choose here center point arc, 3-point arc. Okay, mirror this arc against center line and define some radius 17. Okay, now this geometry is fully defined. Select extruded boss, keep here up to surface and select opposite surface, this surface. Now see the teeth. Okay, merge result. Now we need to make multiple number of thread. So here select view temporary axis Select this center temporary axis, choose here circular pattern and select the pattern. Select this directly extruded body, make 32 numbers. OK. Now height temporary axis. See, select this face or select directly right plane, sketch normal and draw here one circle. Keep the diameter 40 mm and extrude. Keep 36 mm and end condition mid plane. OK. Select this face, sketch, and here we want to make shaft hole. Circle 20 mm. Exit. Make sure this construction line vertical. Create one relation. Select both the end points of line and mid center line symmetric. OK. Line. Exit. Again choose line and draw up to this circle. Exit. Now let's define this gap. 12 mm, 8 mm. OK. Trim entity and trim this inside lines. Now our geometry is fully defined. Select extruded cut. Keep the mid plane end condition through all. OK. See the shaft hole created. Again select this surface, sketch, and here we want to make some cutouts. Create two circles. This one let's say 100 also less, 110. OK. And define this inside 48. OK. Select extruded cut. And keep the depth 3 mm only. See, select inside, sketch normal and draw one more circle. Select for construction. OK. And define. .5 mm. OK. Circle and draw one circle here and let's keep diameter 13 mm. OK. Now select this center point and select here circular sketch pattern. Select this circle and make 6-7 numbers, 360-degree equal spacing. OK. Select extruded cut. Now this all holes going to cut through all. OK. Now this is our gear. We will assign some material to this gear. Brush brass. I think this is quite better. Okay, let's choose polished brass. Save. Part number 6, gear 2. Save. Let's see the next part here. Piston pin, the next part. Right plane sketch and define here circle, inner and outer circle. Outer keep 18 mm and inner keeps 14 mm. Okay, let's extrude it. Here keep end condition mid plane and the length 48 mm. Okay, and let's define the material steel, polished steel. Save part number 7, pin. Piston pin. Let's do the next part, shaft rod. Top plane sketch and draw a circle 20 mm. Okay, and extrude it up to 45 mm. Okay, choose fillet 5 mm and select bottom edge. Okay, now select the top face sketch and here also draw a small face circle. (8 mm). Okay, and extrude it up to 162 mm. Okay, now again select the top face sketch, click here offset entities, keep here 2 mm. Okay, now see the offset. If you will check the diameter, 12 mm. Okay, now select extruded boss, only 2 mm thickness. Okay, that's it. Now select this time right plane sketch, select this line, convert entity. Now it is straight line. A center line and keep the height 3 mm. Okay, select spline, select this point to this point, exit. That's it. Select extruded boss. Keep mid plane end condition and 5 mm. Okay. Now select this surface sketch. Draw here 2 circles. One is similar to this circle and one is bigger. Okay, 16 mm. Extruded cut, reverse direction. Okay, so that we will cut these outer faces. Fillet, keep 1 mm, select this face. Okay, again choose fillet 10 mm and come down and select inside edge. Okay, define the material color, the full I prefer red. Cancel it, select the body, and we will assign some solid color. Solid, red solid. This is quite better, it looks sober. Save. Part number 8, rod. Save. Do the next part, shaft. Right plane sketch. First we will create a circle and keep the diameter 10 mm and extrude it, and extrude up to 200 mm long. Okay. Choose chamfer at both the end. So select both the end. 1 mm 45 degree. Okay. That's it. Now again choose right plane sketch, and here draw a bigger circle, like let's say 14 mm. Select extruded boss. Only 10 mm. Select here offset 70 mm. Now let's see, 70 mm from right plane. Okay. See. Now let's give the material to the shaft. Metal and let's say copper, polished copper. Save. Part number 9, shaft. The next part here, engine valve. So right plane sketch line and start from origin point. Draw a line downward direction. Connect, exit. Overall length 80 mm. 11 mm, 3 mm. 2.5 mm. 3 mm, 5 mm, 1 mm. Now .5, okay. Now let's revolve this body. Select this outer line or mid line. Okay. Now fillet 6 mm and select this inside edge. Okay. Let's do the chamfer. Distance 1/2. Select clear. Select this outer edge only. Oh, okay. Now it's time to chamfer 1.5. Select the top face sketch. Now it's time to define some material. So let's define some solid material. So it's easy to distinguish while it's operating. save part number 10 valve. Now let's do the next part, valve retainer, spring retainer. The next part here is valve spring retainer. Right plane, sketch, select line, exit, center line and draw one vertical center line, exit, select this line, make relation, select this line, vertical relation, make first one more relation, select origin point and this line horizontal, 5 mm, 3 mm and the bottom line 2 mm, and let's keep the gap 1.5 mm. Select revolve boss base. Okay. See, let's say steel, polished steel, and okay, keep polished steel. Save part number 11, valve spring retainer. Save. Now here the next part is retainer. Right plane, sketch, center line, draw vertical center line, that's it, line, and start from here, connect, exit. Now this is the our one geometry. We will make some relation. Make these 2 points horizontal. Five mm, 12.5 mm. Start from bottom line. 1.5 mm, 3.5 mm, 4.5 mm, 4 mm. This 6.5 and it is 4 mm. Now two mm, again select and vertical also 2 mm. One mm and this keep 2 mm. Okay. Now select these two lines, make relation parallel. Okay. Now see here, this mid 1 mm. Okay. Now this distance also we defined. Okay. Now select here fully defined sketch, calculate. Okay. I think everything we defined, nothing is balanced here. Cancel. Select here revolve boss base. Center line selected. Okay. And for the retainer, choose here iron, matte iron. Sand blasted iron. See, save. Retainer. Let's see the next part. Here the next part is camshaft. Select right plane, sketch and define a circle. Let's say the diameter is 20 mm. Okay. Select extruded boss. Here first dimension select 75. Select reverse direction. Direction 2, 125 mm. Okay. Now this is our dimensions. Now select right plane, sketch, normal, and here we will make some geometry. Diameter 24 mm. Connect these 2 points. Again choose circle and draw a circle. Let's keep the diameter 10 mm. Okay. Now here select 3-point arc. Okay. Again select from this point to this arc, exit. Now here we want to trim some unnecessary part, so choose here power trim, just press and drag. See, okay. Now let's prepare some relations. Tangent, tangent, make again undo. First define this radius 16 mm, (40 mm), and this one 10 mm already defined. Okay. Now let's try to make 10 tangent. Okay, and here also let's make tangent and select the last one, tangent. Okay. Now choose smart dimension, select both the end point, see, and select this arc. (12.5). Okay, this is our exact geometry. Select extruded boss and keep here 15 and end condition mid plane, but we want to shift it, so select here offset 15 mm from this direction, see, and make sure this unmerged result, we want to mirror this, so make sure unmerged result, okay, see. Now let's try to mirror, select right plane, mirror, select this body, okay. Now go to feature and here select one option, move and copy, select this body, select translate and rotate, we want to rotate this body, so select rotation, select here temporary axis, select this axis 90 degree, we selected the rod center axis and see we want to rotate it up to 90 degree, select here copy, no need copy, okay, see it's rotate. Now hide this shaft, see, now top plane and create one plane just above the top plane 10 mm, okay. Now select this top plane 1, sketch normal, first draw a midpoint, then select here center point straight slot, exit. Now let's define, select both the end point of slot 20 mm and the distance from outer edge 8 mm and keep the radius 4 mm, okay. Select extruded cut and cut up to, keep the depth 4 mm, okay. Now see, now hide this plane, now this is our camshaft, let's define some material, polished steel, save, this is part number 13, camshaft, save. The next part here is rocker arm, so select front right plane, sketch, select circle, draw 2 circles, one more circle, exit. Select these 2 circle equal, center line, connect these 2 lines, again draw one line and connect with this circle, horizontal. Let's define, the gap is 40 mm, 25 mm, 18 mm, 10 mm, 10.9 mm. Make it 11 mm. And this distance 8 mm. Okay. Now choose here 3-point arc. Select this circle to this circle, and again choose this circle to this circle, and the third one again select these two circles, exit. Select these two lines, tangent, here also tangent, and select this end, tangent. Let's define keep radius 30, 20 mm. Okay, it's by default. Now select this circle and arc, tangent relation. Choose here also same tangent relation, and this end also same tangent relation. Okay, see our geometry is fully defined. So select extruded boss. Now this time we will extrude only these two circles. Keep here mid plane 8 mm. Okay. See. Now again choose the sketch, extruded, this face and this face, mid plane only 5 mm. Make sure merge result. Okay. Sketch 1, extrude, select mid circle, end condition always mid plane, and 20 mm the width length. Okay. See here, fillet, F2, select this edges in both side 2 mm. Okay. See here. Now create one plane, top plane, 5 mm and flip reverse direction. Okay. Now select this plane, sketch normal, and here draw a circle and keep the diameter 10 mm and distance from origin point 25 mm. Okay. Select origin point and circle center point vertical. Okay. Now select extruded boss. Keep only 6 mm. See here. An angle 10 degree. Okay. Now hide this plane. Fillet 0.5 mm and select this face. Delete this edge. Okay. Now it's time to define the material to rocker arm. Select the full body, and we will define cast stainless steel, and let's make some color to it. This is quite better. Okay, now save. Engine, just find out engine where, and this is our part number 14, rocker arm. Now we will start the sub assembly of engine, some parts, piston. Here let's do the sub assembly of valve. Select here new assembly. Okay, this is the SolidWorks assembly window. Let's browse. First choose valve, open. Now browse the another component. Choose here valve and retainer. This is retainer, this is valve. Met, select this and this hole. Concentric relation, okay. Select this face and this face. Coincident, okay. Select this face and this face. Concentric relation, okay. It's fixed, no need to move any. So this is our valve assembly, valve sub assembly. Now save. Valve sub assembly, save. Let's do the further assembly. Now here let's start the assembly of final assembly of single cylinder engine. New assembly, okay. Let's browse the first part, crankshaft. Keep background white, okay. Now select here axis, right plane and origin point. See, is going to create one axis, point and face plane, okay. Now right click on this and float. Now this part is moving. It should be visible. Select here axis, view axis. Now it is visible. Now select matte. Select this face, concentric, okay. Now choose the right plane of assembly and open the crank and right plane of crank. See, it's going to meet coincident relation, okay. Okay. Now let's browse the other parts. Select here, press Ctrl key, piston, connecting rod cover, and piston pin. Open. Piston, connecting rod, cover, and pin. It's time to connect. Select here mat. Select this circular face and this face. Select here concentric. Okay. Select this face and this face. Coincident. Okay. Now select this pin outside and inside hole. Concentric relation. Okay. Now here find out width mat. Select piston, both the end of piston, and a pin and piston, both the end. See, it's going to fix in the mid position. Okay. A standard mat. Select these two faces. Make it reverse. Cancel it. Again choose mat. Select these two faces. Flip direction. Okay, coincident. Now see. Now select both the holes. Concentric. Okay. Concentric. Okay. Now see, it is fixed here. Now it's time to fix with this crankshaft. Mat. Clear. Select this concentric relation. Okay. Now find out here width mat. Select these two faces. And the same for this two faces. Now see, it's going to fix in the center position. Select OK. OK. Now it is fixed here. See, piston rotating. Okay. Let's browse the camshaft. Mat. Select these two faces and make sure coincide. Okay. Now here we want to sketch one geometry, then we will fix this camshaft. One relation we created. Now select this face, sketch, normal. Go to layout, select here center line and start to draw from this center point and make one triangle. Exit. Let's define 65 mm and this triangular diagonal keep 97 mm. Okay. Now simply exit. Now choose here mat. Select this center point and select this circular face. Make relation symmetric, concentric. Okay. Now see, this is fixed here. Now it's time to add some more parts. We will do one thing. Now select small gear, gear 1 and gear 2. This is gear 1, this is gear 2. Mat. select this face, concentric, okay, drag inside, select these two faces, coincident, okay. Now we want to mat this pinhole. You can see inside we created one pinhole, so select the clear, select the edge, only edge, not edge, and edge of crankshaft, coincident, okay. Now see this gear 1 fixed. Now select gear 2, camshaft, concentric, okay, drag camshaft and gear 2, coincident, okay. Now see, okay, the gears is going to met. Now you can see, select the edge of gear, inside edge, and edge of this hole, coincident, okay. Okay, now you can see it is rotating like this. Now still we need to give some more relation, just hide. You can hide this axis 1. Now browse the another part, shaft. Select here right plane, sketch, normal, and here we will make one geometry. Select center line and start from origin point. Exit. Make sure this line vertical and this is horizontal. Let's define the dimension. 300 mm, 40 mm, okay. Now select right plane. Now exit. This is our geometry created. Now select right plane and select here axis, and we want to create one axis. Select this end point. You can see one perpendicular axis going to create face, okay. Now select this mat and this axis, concentric relation, okay. Select face of camshaft and face of shaft, coincident, okay. Now here also we will clear one more relation. Select this line and this piston and select here concentric relation, see, okay, okay. Now let's see how the piston moving up and down. See, piston moving in one line, it is not rotating here and there. So this is our main aim. Now hide this axis. Let's browse the another part. Now it's time to bring rocker arm. Press Ctrl key and copy and make one more. Okay. Now this face here, it's better. Mat. Select the shaft and hole. Concentric. Okay. select this face and this face, coincident. Okay, select for the second rocker arm concentric mat, this valve and this valve coincident. Now both fixed here. Okay, now it's time to make some relation. We want to create one plane. Select front plane, plane, exit, show sketch 1. Now select front plane, then choose here plane, and here select this point. Okay, now here we created one plane, so select this plane, sketch, first select normal view. Okay, now here we want to create some geometry, center line, exit, again choose center line and draw one vertical line. Both lines should be vertical. Now the very important thing, this distance 30 mm, and from one end 15 mm. Okay, now the length is doesn't matter. Now it is in center of this camshaft, exit. Now let's bring our next part. Assembly, insert, and bring rod. Press Ctrl key, select the rod and drag and drop, and we created 2 rods. That's it. Now we will create some relations. Select this rod, select right plane of rod, press Ctrl key and right plane, met. Clear, select here parallel only. Okay, okay. Now select this rod, rod 2, right plane, go up, right plane, met. Here also select parallel mat, not coincident, make sure. Okay, okay. Now mat, select first axis, first line what we created in our previous sketch. Select this, select here concentric relation. Okay, again select the second sketch line, and select concentric. Okay, now you can see both in the center of camshaft. Now it's going to define a very important relation. Now you can hide this geometry, sketch 2, hide. Mat, go to here mechanical mat and choose cam. Now here we are going to make camshaft relation. First define the cam. So select this, supposed to be cam, and this is the face, and here select the follower. Select 1, 2, 3. Okay, now see it is met here. Okay, now layer. This is the face of cam, and select this. See matte here. Okay, okay, okay. Now let's try to rotate and we will understand whether it is working or not. Now see, it is working. Okay, it's working perfectly. Now it's time to define here. Matte, select the upper face and this face. Tangent relation. Okay. This surface and this face. Tangent relation. Okay. Now let's again rotate. See the camshaft and rocker arm relation we created. Okay. Now it's time to add some other part. Browse our assembly. Valve sub-assembly. Now select, or directly you can bring again valve sub-assembly. We need 2 assemblies. Okay. Now to fix this we need to create a geometry. So let's do one thing. We will create first a geometry. So select front plane, sketch, normal. This is sketch, hide it. Now go to layout, center line, and start from origin. Exit, and again mm, 15 mm. Okay. Again choose center line. Select both the lines and make relation equal. Okay. Now define it. Any dimension, it's up to 30 mm. (200 mm), so that our geometry will be fixed, perfect. Now exit. Now see, just drop down the piston. Now see this geometry we created in front plane. Now with the help of this geometry we will fix this valve assembly. Go to assembly, choose here matte. Select first line and valve body and select here concentric relation. Okay. Second valve, same concentric relation. Okay. Now this valve fix with this. Now select this face and this face and tangent relation. Okay. The same here, this face and this face, tangent relation. Okay. Okay. Now let's try to see valve going up and down. Now a very important relation, gear relation. Now hide all the geometry, hide sketch, and the last sketch also hide, no need to show here. Select this face and see the front face and just change the gear, set the gear, because we are going to make a very important relation in engine, gear relation. On behalf of this gear, it will run the whole engine. So choose met, go to mechanical met, and you will find here gear. Now select first this face and second this face. Now the first face make ratio 20, because the gear is small, and the bigger one keep ratio 40. Okay. Now let's little rotate. See, so this is our engine is ready. It is a simple single cylinder engine. This is just a concept how the engine works and how engine rotates. I am sure it helps the new beginners in SolidWorks, and you will learn a lot from this tutorial. I hope you like it. Let's do one thing, save this engine, save here final assembly. Now let's bring little expand. Okay. Now save it. Now right click on the interface or this ribbon and click here motion manager. Now go to motion manager. First do one thing, first open, first select here motion study properties, select 25 RPM. Now assembly drag up to 20, choose motor, select this face, reverse, RPM. You can see here very carefully. Keep rotary motor. Okay. Now select here calculate. It will take few seconds more for calculation. Once it's calculated, then it will play smoothly. If you have better graphics card, the motion works better. So it's near to finish. Just play. See, it's playing very beautifully. Now drop down, again play. Now you can see this engine rotating. I hope you like it. Please subscribe our channel for more video and more projects in SolidWorks. Don't forget to share and like our video. I hope you like it. Thanks for watching. If you want to save it, okay, if you want to save this, I forgot to show you, just save this animation, click save. This is the ratio 25 rpm, and you can give here any name and anything. Piston assembly, I select desktop, save, and here uncheck keyframe. Okay, now once you save it, it will automatically restart the calculation, and it will take the same time what it requires for calculation. So let's see. Now it is saved in your system. If you, let's see, for view and play, see each and every drawing, we can see how it's playing. See here, so you can see all the views from every corner. So I hope you like it. Thanks for watching and have a good day.